Welcome, your student. Today we shall continue our chapters polynomials. Today we shall discuss factor theorem. So let's start our class. See, what is factor theorem? Suppose we have a polynomial fx be a polynomial whose degree is greater than 1. It means what? Polynomial is which type of? Either it is quadratic, either it is cubic, either it is biquadratic, but it is not linear. In factor theorems, a polynomial whose degree is greater than 1. Greater than 1 means what? Except linear polynomial, we have to take either quadratic, either cubic and biquadratics. And let small a be any real numbers. Small a be any real numbers. Then we have two cases. In case first, if f of a is equals to 0, it means what? A be any real number, and we substitute in this. If it becomes 0, then we said what? X minus a is a factor of polynomial fx. Now case 2, it is just a reverse way. If x minus a is a factor of polynomial fx, then fa is equals to 0. It is just reverse. This is our factors theorem. Now we can understand by some example. Now this is example first. It said so that x minus 3 is a factor of the polynomial fx is equals to x cube plus x square minus 17x plus 15. One question is said, we have to show that x minus 3 is a factor of these polynomials. See, apply the above concept of factor theorems. By the factor theorem, x minus 3 will be the factor of fx if f of 3 is equals to 0. Apply the concept first. Now see what we do. We have to calculate f of 3. In a place of x, just we have to substitute is 3. This becomes 3 cube plus 3 square, because we have x square, 17x, 17 to 3 plus 15. I hope up to this stage clear. Now calculate it. This becomes 27, this becomes 9, this becomes 51, and this becomes 5. Clear? Now solve a 1 and it becomes 0. Becomes 0. This implies that, or therefore, from concept of first, if f of a is equal to 0, then what we said, x minus a is a factor. Then you have to find f of 3 equals to 0. Therefore, what we said, x minus 3 is a factor of polynomial fx. Now what we do in whole process, I repeat once again. See what question is said, x minus 3 is a factor of polynomial this. We have to show x minus 3 is a factor of polynomials this. First what we do, we know that by factor theorem, if x minus 3 will be a factor of fx, then f of 3 will be 0. F of 3 will be, if x minus a is a factor of polynomial fx, then f of a will be 0. In a place of a here is 3, then f of 3 equal to 0. and we know that how we calculate the values of the polynomial. First, what we do, in a place of x, just substitute is 3. So this is 3x cube, 3 cube plus x square, 3 square minus 17x, 17 to 3 plus 15. After you calculating, it becomes 0. Therefore, what we said, x minus 3 is a factor of polynomial fx. I hope this one is clear to you. Take another question. Question is said, find the value of small a for which x minus a is a factor of the polynomial fx is equals to x to the power 5 minus a square x cube 2x a minus 3. Apply the same concept. In this question, we have to calculate the value of a if x minus a is a factor of these polynomials. Again, same statement. Apply the factor theorems. Directly you write x minus a is a factor of polynomial fx, which is x to the power 5 minus a square x cube plus 2x plus a minus 3. This is the polynomials. Then what we do, we have to calculate f of a is equals to 0 because x minus a is a factor of these polynomials. In a place of x, substitute here a. This becomes a to the power 5. This becomes a square and a cube. This is 2a plus a minus 3 is equals to 0. Now this becomes a to the power 5. Now base is same, power will be added. A to the power 5, 2a plus a becomes 3a minus 3 is equals to 0. Like term, opposite sign, cancel out each other. Therefore 3a is equals to 3. The value of a will be 1. I hope this one is clear to you.